My name is Clinton Ford, VP of Product Marketing at Unravel, and I'm joined today by Eric Chu, our VP of Product. Today, we're going to talk about data observability and FinOps for high-volume users of Snowflake. We will discuss how you can maximize the business value from your data assets at today's speed and scale through performance and efficiency enabled by AI that is purpose-built for your data cloud. Thanks for joining us, Eric.
Hi, Clinton. Hello, everyone.
So let's dive in and take a look at our agenda. Really excited to share some of this content with you today. Okay, so first, let's take a look at some of the common business challenges. So the scale and pace at which data is being leveraged for AI and machine learning is driving exponential consumption. As companies look to differentiate through generative AI, such as large language models or LLMs, demand for diverse and production-ready data pipelines is skyrocketing. Enterprises are finding that the only way to efficiently deliver cloud data analytics at that scale is to use AI. And AI is enabling greater efficiency than ever before. And now with AI to automate routine tasks, enterprises are empowering their data team to spend less time on routine and mundane tasks and more time innovating. So there are four things that we frequently hear from customers that are creating friction and resistance for their organization. Is the demands of AI are getting higher and keeping data pipelines running is getting more complicated. So first of all, data spend forecasting is like a roller coaster. It's difficult to reliably predict, disrupting financial operations. Second, the pace of adding new data workloads is limited by budget and skilled resources available. It's like chaining an anchor to your race car. Budget and staff resource constraints slow cloud data adoption. New AI models are exponentially increasing the scale of data volume and data pipeline complexity, thereby adding even more pressure to existing budget limitation issues. And the mean time to repair critical data applications is slow due to the tech stack complexity and just toilsome metadata correlation that ties up critical skilled resources needed for faster innovation. So first of all, cloud data costs are exploding. Within the overall cloud bill, data management services are the fastest growing category of cloud service spending, representing about 39% of the typical cloud bill. And 81% of 753 global cloud decision makers and users surveyed reported that managing cloud spend is a top challenge. So budget and staff constraints are also creating real risks to data and AI projects. Production environments are statically over-provisioned and therefore overly costly. On premises, 30% utilization is common, but it's all capital expenditures or CapEx. And as long as it's within budget, no one has traditionally cared about the waste. However, in the cloud, you pay for that excess resource monthly, forcing you to confront the ongoing cost of the waste. And the cloud skills gap has reached an incredible near crisis level in many organizations. So revenue creation through digital transformation requires talent engagement that is currently scarce and difficult to acquire and maintain. So lack of skills remains, a top barrier to infrastructure monetization and modernization. So data is foundational to AI, yet unstructured data remains largely untapped. And so organizations today view the cloud as a highly strategic platform for digital transformation. But this requires, cloud providers to offer more sophisticated capabilities as the competition for digital services heats up. For example, generative AI is supported by large language models, which require powerful and highly scalable computing capabilities to process data in real time. Data pipelines are becoming increasingly complex and slowing innovation. For example, among the various reasons that data projects in manufacturing stall is the issue that legacy technology, including on-premises and cloud data warehouses, are too complex and costly for growing volumes of data from connected products and operations. So the inefficient usage of Snowflake can occur at various levels. For example, at the warehouse level. So a warehouse that is too large or has too many, resources for a given workload will be underutilized and incur a higher cost than necessary. Whereas the opposite, the warehouse being too small or having too few resources will not do the work fast enough. Next is the workload. So the democratization of AI results in rapidly increasing number of users using SQL or structured query language, many of whom focus on getting value out of the data and do not really think about the performance and the cost aspects of running their SQL queries on Snowflake. So this can lead to costly practices such as a select star just to check out the schema, running long queries that time out repeatedly without checking out why it's timing out, and expensive joins such as a Cartesian product. And then data. So often there's either no or poorly chosen cluster or partition keys, and this leads to many table scans. And unused tables accumulate over time, and by the time users notice the data explosion, they have a hard time knowing which tables can safely be deleted. So in order to overcome the 4 common business challenges, go faster, and gain a competitive advantage, Snowflake users really need visibility for cost allocation, for chargeback, and accurately predicting spend at the query and the user level. They need AI-powered insights to run more data workloads within existing budgets, and alerts so that they can confidently launch new data applications faster and reliably achieve their SLAs. So how does Unravel enable organizations with the visibility, the insights, and the alerts? We provide deep, granular visibility, AI-powered insights engine, and alerts for immediate responses. And with that, now I'm excited to hand it over to Eric Chu, our VP of Product, to share about this new product, Unravel for Snowflake, and to provide a demo. So Eric, over to you.
Thank you, Clinton. Hello, everyone again. I'm going to share my screen and go on. All right, I hope everyone can see my screen. Unravel provides AI-powered FinOps and performance optimization for Snowflake. Now, in FinOps, there are 3 phases to consider. First, inform, which is about what you're paying, who is paying, and how much are they paying over a period of time. The second phase, optimize, is about identifying inefficiencies in your usage and what actions you should take to reduce that cost and get the most out of Snowflake. The third phase is about taking actions on the recommendations of what you should do about your inefficiencies. And for all these 3 phases, Unravel provides help to you. For the inform phase, I'm going to show in a demo in a second, a health check feature that gives you a top-down summary of cost, usage, recommendations on your cost and performance inefficiencies, and most importantly, the annualized savings that you could get by taking these recommendations. I will also show you the cost 360 view with that includes not just the trends and chargeback, but also the top K warehouses, users, and queries. So you could easily identify what are the most impactful warehouse users and queries that you should address. With that, you can also drill down to look at the detailed warehouses and queries with extensive KPIs. When it comes to debugging, you can use Unravel to do a side-by-side comparison of queries to quickly see what's the difference between the 2. I'm also going to talk a little bit more about the insights in this webinar. When it comes to making your cost efficient and the performance fast, there are 2 biggest areas to consider. One is the warehouse level insights, and the second one is the SQL level insights. So without further ado, I'm going to jump into the demo. So what you're looking at now is after you have logged into Unravel, you will see the insights overview, which is the health check feature that we provide. Without doing anything, Unravel will analyze the last 15 days of your workload, and it would come up with updated once a day. And here you can see, first you'll see the total cost from this 15-day period. Then you have the projected annualized cost for the whole year based on this period. And then you also see the projected savings based on our analysis. Below that, you see a summary of the usage, which includes credits, how many users, how many warehouses, queries, and tables, and the storage. Now, the most interesting part is the optimization. What insights have we found? So here we do it in two categories. One is the savings for warehouses, and the other one is the savings for queries. On the left, you see the insights about warehouse, the annualized savings, and then on the right, you see the same for queries, which are broken down into 4 categories of insights: join inefficiency, performance, projection inefficiency, and anti-patterns. I'll go into details later. Scrolling down, you see the most expensive query signatures, because so query signatures are the SQL query template of many different runs that share the same template, especially when the queries are recurring. If the query is actually inefficient, then the cost inefficiency will accumulate very fast and have a large impact. So here we wanted to show you the top 10 most expensive query signatures, so that you could see what are the inefficiencies being shown, and then you could drill down into the whole list of the queries that are having those problems. And at the end of the health check, we also tell you suggestions about what kind of alerting policies you should set. For example, here we tell you that if you set an alert for the query duration based on the 99th percentile of your workload, and kill all those queries, then you can save an estimated of $12,000 per year. Of course, this is based on our sample data. In the customers that have already used us for Snowflake, we observe much larger values. Before I go into the detail of the insights, I'm going to go back to my slide deck to give a summary of the different types of insights that we do. So I mentioned earlier that we're doing warehouse level and SQL level, because those are the 2 biggest areas for improvement. Now, for warehouse, we know that Snowflake pricing is based on compute, storage, and some other services. Among them, the compute pricing is the dominant factor. Now, the compute pricing is based on how many warehouses you have, what are the warehouse sizes, how many clusters you have for each warehouse, and the duration of how long they have been running. And all those need to be fit to your workload. Almost everybody knows that if you underutilize the resource that you have allocated, then you are overpaying. And so this really, it's a bin packing problem where you're trying to, based on the workload you have, find the right size of the warehouses. Now, at Unravel, we consider this at 3 levels. First, we optimize across warehouses, where we are trying to look at multiple underutilized warehouses that we can consolidate into one. Now, this is the first thing we do when it comes to warehouse level insights, because when you consolidate multiple warehouses into one, there is usually a less, you can reuse the data, you can reuse the cache, and there's a less idle time period. After that consideration, we're going to look at individual warehouse optimization in 2 aspects. One is scaling up, and the other one is scaling out. In scaling up, we're looking at whether you can downsize, any underutilized warehouses based on the workload. And that is more for the cost consideration. And then for scaling out, we are looking at the min and the max clusters of a warehouse. And based on your workload, we will tell you whether the min and max that you have set is good, is reasonable. And if not, all of these insights, we're going to give you a concrete recommendation. So now let us stop here and go back to our demo. Here you will see now on this part, you'll see these 3 types of categories of these 3 warehouse insights. Now, if I open up this consolidate warehouses, you see the top 5. In our data set, we only have 4, but we'll give you the top 5 instances of the recommendation about consolidate warehouses. Now, let's look at this second one, which is telling you to consider consolidating these warehouses, which are the SP medium after SP medium and RTM in our example, into one warehouse of size medium. So you might wonder, how do we look at, how do we pick these warehouses? So we pick them based on the workload, whether they are using the same common data set, and whether their schedules are compatible. So now let me open up the warehouse detail pages of some of these warehouses. So these 3 warehouses, you can see, are spending, we're spending $20.68, $49, and $71, respectively. Now, if we open up the new one that we have consolidated them into one, you see that with all the 3 workloads that you can combine into running on one single warehouse, you actually just use $46 instead. So that is almost $90 of savings just in this small example. Now, if you look at the other example where you have the downsized warehouses, here we're telling you that for each of these warehouses, we have analyzed them, and we will tell you that based on the workload, you actually don't need such a big size. You can downsize them into a concrete recommendation of what size we use, right? Here you see them, all of these recommendations are extra small, but if you have a bigger data set, bigger workload, then they will also tell you to use different sizes. The smallest one that can fit without affecting your performance. So now let's take a look at this this example where we are seeing that for this warehouse, downsize from XX large to extra small. So now let's take a look at that. So this is the XX large warehouse where that we are spending about $750 for this warehouse. Now, I'm going to open up the other example where we have already downsized it. Then you can actually reduce it down to $1.83. Now, the last one, adjust min and max. Here we're going to look at the scale out factor, where you have picked the warehouse size, but you have also set the min and max for the auto scaling configuration. And what we have told you here is that based on the workload and the time schedule, we'll tell you what is the number of minimum clusters or the maximum clusters that you should set the auto scaling configurations to. In this example, we're telling you that the minimum number should be set to 1. So let's take a look at what we're doing. So here we can see not just the cost, which is $49, but also the KPIs, including the min and max setting. In this example, we are saying we have set it to min being 5 and max being 5 without knowing about what workload we're doing. So obviously this is underutilized. And now if we set it to extra small, which means, oh, sorry, not extra small, but change the min and max to 1, then the size would remain the same. Then you can see that the cost has gone down from $49 to $20, almost half that price. So all of these examples underscored the importance and the impact of the right configuration. Now, to sum up, the challenge in doing this is understanding the workload. The configurations, the options, those are pretty well known. People know that they can consolidate multiple warehouses to one. They can pick warehouse size. They can specify the min and max for auto scaling. But the challenge is knowing what are the right values. And the right values depend on your workload. If you don't have the analysis and you have to simply pick those based on trial and error, it could cost you even more. So what Unravel does is once you have hooked up your Snowflake account to Unravel, we would automatically analyze all these warehouses and queries and generate this insights automatically. Besides telling you at a high level what you should do, we would also give you concrete recommendations. So these are the benefits of using Unravel. Now, let's take a look at the query level insights. Here I show you we have considered 4 categories of query level insights: join inefficiency, performance, projection inefficiencies, and anti-patterns. So what are they about? Now, let's go back to the slide deck. Here, for join inefficiency, we're referring to inefficient joins, basically, which can be of different types. Sometimes people explicitly specify keyword cross-join in the query. Sometimes they don't do it, they just do keys, and then that would be a Cartesian product. And sometimes without even detecting those, we see that the data set from the join operation has, there's a data explosion. So all these different variations of join inefficiencies we're able to detect, and we'll show you automatically in a SQL query analysis. Now, for performance, we're referring to examples such as there is an operator that is the dominant factor for why your query is slow. Anytime when a query is slow, it typically also means it's expensive. So identifying what is the slow operator is often the first step of finding out what is why a query is inefficient or expensive. Another type of SQL insight that we have looked into is move the queries to the right size of the warehouse. So this could be moving a query that uses a lot of resources from a small warehouse to a large warehouse, so it can be faster and it can be faster. Right. The other way around is to move a query that is actually using a little resource, but it is being run in a really large warehouse. In that case, you can move them to a smaller warehouse that doesn't need that much resource. And so if you do all again, going back to the bin packing example, pick the right size of warehouses for your right queries, then you can eventually reduce the need for really large warehouses. You can start getting rid of the underutilized warehouses. Projection inefficiency is also a common pitfall where users often do select star, or they select a lot of columns. And what we do is we raise these red flags so people can review and judge whether they are these queries are these selections are really needed. And then lastly, anti-patterns. So these are getting pretty advanced level of checking for bad practices. For example, union versus union all. Do you really need union? If not, you can use union all, which is a back semantics, and you can save some money. Or you should use distinct or aggregation in the subquery, avoid using order by without limit, and avoid single row inserts. So all these are bad practices that people should avoid. And so we call them as anti-patterns. Now, sometimes when these happen, it doesn't mean that they are wrong. So semantically, we cannot tell. Users have to eventually decide. But what often happens is people don't even realize that. They don't think about that. So what we can do is we raise these red flags so people know about that these are being done, and they could review and make the decisions whether to rewrite them. So now going back to the health check, here, if I click on join inefficiency, you can see you're going to the queries page where you're going to see all the inefficiencies related with respect to join inefficiencies being selected. So this acts as a filter on all the queries that we're monitoring and show you the ones that have this type of problems. Now you can drill down into looking at the details. So here you can, we're in the query detail page, and you can see all the important KPIs like the cost, the status, start time, duration, etc. How much data you have scanned, who is the user, which warehouse has it run on, and you can look at the query text to know what they're talking, what this query is about. But most importantly, we show you the details of the inefficiencies. So here, for example, we tell you that a join condition produces more output records than input records, and we ask you to review the join condition. And here you can see other types of insights. For example, this one is the anti-pattern that I mentioned, and the slow operator that that I mentioned. Now, let us take a look at the potential difference of an expensive join versus a reasonable join. So I'm going to pick an example where I will use this cross join. So here you can see the query text. We are doing cross join here, and we can detect that, and we will tell you that, hey, instead of using a cross join, consider doing an inner join. So now you can see that the query takes a total duration of 1 hour, 41 minutes, and it costs about $6, almost $7. Now let's see if we use an inner join, what is the performance like? Here you can see we have rewritten the query, and the duration has gone down to 21 seconds from 1 hour and 41 minutes. And the cost has gone down from $6.7 to 2 cents. So just a simple rewrite of the query makes a huge difference in terms of the duration and the cost. And of course, this is our toy data set. I think this is TPCDS. Now imagine a real data set. You can easily spend hundreds of thousands of dollars per query. Now, going back to these other projection inefficiencies and anti-patterns, you can see that we are able to filter out all the different insights. Let me pick an anti-patterns. As I mentioned earlier, in the end, we cannot be sure whether this is intended or by design from the user who ran this query. So all these anti-patterns are suggestions. We need people to review. Now, how our customers have been using us for Databricks SQL or here is that they have used our latest feature, which is still in private preview. So it is coming soon for Snowflake, but it's already running for our support for Databricks, our CI/CD support, where they could connect Unravel to their CI/CD, such as GitHub. And so what that means is when the developers are looking at these queries, where they often have to run them on a dev environment before running them on production, Once those environments are hooked up to Unravel, we will automatically detect all these queries, come up with these insights, and show these insights in their CI/CD. So in the specifically in the pull request. So some of our customers have leveraged this feature and required the engineering team to review and act on all the query level inefficiencies that Unravel has surfaced. So this is a great chance for them to automatically see all the red flags, decide on whether they are really needed, and take actions. So they some of the customers of ours, they require the engineers to address these inefficiencies before they can accept and merge the pull request for the query to be run on production. So this has helped them enforce the optimization and gone into the governance aspect of FinOps. Now, I'm going to quickly show other features. So here I just show you the all the query detail page, where you can see all the queries, and then you can do all kinds of filter here. Such as select filter by the user, by the warehouse, by the status, and the different insights that we support. You can also filter by cost, duration, and query signature. Here you can also filter based on the time. So just a very powerful way for people to browse and find the queries that they want based on their criteria. Now, when you are trying to understand cost, I mentioned that we provide this cost 360 view, where you come into this dashboard, and this dashboard, we show you first the total cost of the time period that you have selected. The default is 30 days. Then you can see the breakdown across compute, storage, data transfer, the trend of all these, as well as the different breakdown by warehouses, which you can see by the compute, and then also the users and the queries. So this part, I think Snowflake said they're doing the query level cost soon, but at this point, I think it's still in preview, and whereas we're providing that to you. And here you can quickly look at the top queries and top users and drill down from there. We also support chargeback and trends based on tags, which allows you to track the different usage based on your own policies, like departments or teams or projects. Now, the warehouse page will also show you the different warehouse detail, the warehouses that you've been running, and the detail page. So here we are, I think this is, this is probably ran in the past month, so it doesn't show up. And then you can see the queries, which I have shown you, and then you can select any of these two queries to do a query comparison. For the alerting, besides on the governance part, besides the CI/CD, we also support alerting, where we can support alerts based on the duration and the cost, and then people can also customize their own alerts for whatever API that we track, and provide KPI that data that we support, and then we provide the API. So with that, I'm going to take a pause and see if you have any questions.
Thank you so much, Eric. Wow, that was incredible. Really appreciate the demo. Yes, we did have some questions come in during your presentation, so let's just dive into those really quickly. Okay, here's one that came in, Eric. It asks how Unravel differentiates in providing accurate or actionable insights to the users or the frontline team. This is one of the challenges we currently face as end users. Okay, so they're wondering for the end users of Snowflake, how does the Unravel product provide actionable insights for them?
Yeah, so as I mentioned earlier, Unravel is a purpose-built AI that provides real-time insights based on millions of ongoing metadata streams that are continuously interpreted to deliver actionable recommendations for data applications. So these will help you quickly troubleshoot job failures, troubleshoot system performance, and improve code efficiency to help you achieve your SLAs.
Fantastic. Here's another question that came in, Eric, asking, can you elaborate on a couple of use cases that have been deployed by Unravel?
Yeah, sure. So as I mentioned earlier, we have companies and they are in the finance, healthcare, e-commerce, various sectors, and they have successfully implemented the CI/CD practices with Databricks. So these enterprise organizations across different industries leverage us to ensure that code is performant and efficient before it goes into production. So for financial services, if I recall correctly, we have a Fortune Global 500 bank that provides Unravel to their developers as a way to evaluate their pipelines before they do a code release. And then for healthcare, we have one of the largest health insurance providers in the United States that uses Unravel to ensure that its business-critical data applications are optimized for performance, and reliability, and cost in its development environment before they go live in production. We also have another large logistics companies that leverages Unravel to upskill their data teams at scale. They put Unravel in the CI/CD process to ensure that all code and queries are reviewed to ensure they meet the desired quality and efficiency bar before they go into production.
Amazing. Thanks for sharing those, Eric. Looks like there are two questions that came in that are related. One question is, does Unravel require additional compute resources apart from the cloud computing resources? And the other question, similar, was, what are the monitoring mechanisms about the data that we have stored on Unravel?
So the first one is requiring additional compute resources, correct?
That's right. It's asking basically, what additional compute resources? So how much compute does Unravel consume in addition to the workload?
Yeah, so Unravel is a lightweight and agentless adaptive metadata collection process. It uses Snowflake native APIs to get the data we need. Usually it's under 1% of the total resources. What is the second question?
The next question was a little bit related. It says, what are the monitoring mechanisms about the data that we have stored on Unravel? So in other words, how do we monitor and gather the data, and what gets stored into Unravel?
Yeah, so I mentioned earlier, so the data sources comes from Snowflake system tables, and Snowflake provides API. So we basically use these APIs in a very lightweight and agentless process.
Nice. The next question is, what type of data does Unravel store or collect from the users? Is it only metadata that we need?
Yes, only collect metadata and performance data from the jobs, queries, and then the billing data, which all of them come from Snowflake system tables.
Great. Okay, here's a question that came in from an attendee. What is the data governance model in Unravel?
So Unravel is committed to security, and we focus on keeping our clients and the data safe. The solution from Unravel manages customer data based on the 5 SOC trust services criteria. Those are security, availability, processing integrity, confidentiality, and privacy. We use TLS encryption, which is the same standard used by secure websites to secure data in transit and at rest. So we are SOC 2 compliant, and we have earned a Service Organization Control SOC 2 type certification.
Excellent. Okay, great. Let's see. Okay, one other question. Is Unravel offered as a pay-as-you-go model?
Yes, it is. It is available in a pay-as-you-go model. Yeah, I think, Clinton, you can share more information with the audience.
Yes, absolutely. And if you can advance to the next slide there, Eric. Let's see if we can bring this up. Okay, perfect. One of the things that we're offering as part of this launch is a free health check for your Snowflake environment. So if you go to that URL at the bottom there, you can request a free health check. So the things that Eric was showing you, we can actually do an analysis of your metadata before you even take that next step to sign up or to pay anything. We can do this for free. And then, yes, we have different options for pay-as-you-go, as well as for longer-term contracts. And we'd be happy to talk with you some more to understand your needs and see what would be the best fit. So thanks for all of the attendees for joining us today. Really appreciate your time. And Eric, I want to thank you so much for your presentation and the demo. Really great questions from our attendees. Glad we could answer some of those. And if we didn't get to your question during this event, we'd love to follow up with you afterwards. So please feel free to reach out to us. Thank you so much.
Thank you, Clinton. Thank you for coming.
You bet. Thank you, Eric. Thanks, everyone.